Sure, yeah. Energy again, okay. So our energy system has been changing in recent years. So we see more and more wind, solar, and other renewable energy resources in the power grid, right? In the meantime, we do see a lot of trend in the electrification. We see more electrical vehicles, cars, electrical boats, electrical airplanes. These will all add additional load to our general power grid. Right. So as many of us may know that, the power grid has to maintain the balance between the supply and demand all the time, every single second, minutes, hours, to maintain the reliability of the entire power grid. So put wind and solar and many others into a grid will add a lot of variabilities, uncertainty, because wind is not always blowing, solar is not always shining. So that will create challenging for the grid to operate. So our lab is trying to do the optimization techniques, to better modeling, trying to address challenges to make this power grid run more efficiently, more economic, and reliably. So in the meantime, we are also experiencing a lot of extreme events in recent years. Hurricanes, wildfire, extreme hot, extreme cold. Many of us has experienced this cold, the winter storm last year. We lost 3 days, like outage. Right. That will create a lot of problem for the resilience of power grid. How can we make our power system, energy system more resilient to these extreme events? So we can do a lot of resiliency enhancement techniques, such as before the disasters, we can allocate some mobile units, transformers, batteries, even ships, trying to prepare for that. During the middle of the hurricane or extreme events, we can do a lot of change the energy power flow. If certain lines, certain nodes are broken, so we can reroute the energy flow to different critical loads, military base, hospitals, trying to minimize the loss of loads and minimize the damage. And after the disasters, of course, we want to recover the power grid as quickly as possible, restoration. So overall, our lab is working on the energy system challenges to address this reliability, economic efficiency, and resiliency of the power grid. So, thanks.
Thank you.